what we're going to about to talk about is something that is very important when it comes to like vectors. So we have our definition of work, right? So that's force times displacement times cosine of theta. But remember that force and displacement are vectors. And whenever you multiply two vectors together, it'll lead up to a dot product. So for the problems that we have done earlier, there's only, for the most part, a vertical or horizontal component. But there might be cases where the force has a horizontal and vertical component, and the displacement has a horizontal and vertical component. So what you can do is you can use a dot product. So that's basically defined as A times B equals basically the value of the two vectors times the cosine of the angle in between. So like for a visual representation, say this is A and this is B. This would be the angle in between. You can the dot product also can be rewritten as this. So A times B, or A dot B, is equal to AX plus BX plus AY times BY. And what you actually can do, if you're not given the angle, you can actually find the angle in between manually. So the formula for that is the cosine of theta equals the dot product of A and B over the magnitude of A. We use absolute value signs to represent magnitude, so don't actually just, like, if it's a negative number, don't, like, or negative component, don't just absolute value out and then say there. No. So, like, what I mean by the magnitude is, say we have a vector A and we're trying to find its magnitude. You just use Pythagorean's theorem. So that's ax squared plus ay squared, and then you take the square root of that. And then the same can be applied for the magnitude of b. So this is basically how you find the angle in between with this formula right here. So basically you were given an example problem, and you're supposed to find the dot product of A and B if the magnitude of A is 2 and the magnitude of B is 10, and the angle between is pi over 4. So basically what you can do is you can use the angle in between formula, or you can just use 8, or you can use A times B times cosine alpha equals A dot B, whatever one you like. It'll just lead to the same answer because A times B, so that's the magnitudes on the bottom, and then A dot B, and then equals cosine theta. You multiply magnitudes A and B on both sides, you just get the same answer. So when you plug everything in, you should get an answer of 14.14. Components for both in component form. So remember that in component form, this is our x component, and then this is our y component. So now so what we're going to do is we're going to use the formula for the angle in between, cosine theta equals the dot product of A and B over the magnitude of A and B. So when we take the dot product, that'll just be square root of 3 times 0 plus negative 1 times 7. So that'll just equal negative 7. So then we're going to have the magnitudes of A and B. So that would just be, so that would be the square root of 3 squared, then plus negative 1 squared. So the square root and the square cancel out, and then the square root of negative 1 is 1. So 3 plus 1 is 4 equals c squared, and the magnitude is just 2. And then for b, 0 squared is 0, plus 7 squared is 49. So 49 equals c squared, so then the magnitude of b would be 7. Because remember, it's just a vertical vector, like this. So basically we get cosine of theta equals negative 7 times 2 times 7, or you can cancel these out, and then cosine theta equals negative 1/2. And then you take the inverse cosine of that. So inverse cosine of negative 1/2. So then you get 2.0944 radians. Or approximately 2 pi over 3. So next we're going to find the dot product of the vector A equals 3i plus 8j and the vector B equals 5i minus 7j. So don't freak out. This is not like some sort of system of equations. It's just a way of labeling your components. So the coefficient in front of the i's represent the x component, and the coefficient in front of the y's, in front of the j's is the y component. So we can rewrite vectors as 3, 8, and 5, negative 7. Now we can use one of the formulas for the dot product. So that's A times B equals AX times BX plus AY times BY. So when you plug everything in, so that would be A times B, A dot B, and then 3 times 5, and then plus 8 times negative 7, you get an answer of negative 41.